Right now, a quiet multi-trillion-dollar initiative is underway among the world's largest tech conglomerates. Their objective is to physically migrate the infrastructure of artificial intelligence out of our atmosphere and into the vacuum of space. To understand why, you have to look at the immense physical footprint required to keep these systems running down here. Terrestrial data centers already consume vast swaths of land, and their expansion is accelerating. This graph plots AI's electricity demand against global grid capacity. By 2050, AI will consume a tenth of Earth's electricity. North America needs up to 100 gigawatts in 3 years, the equivalent of 100 new nuclear projects. The source of this crisis sits inside hardware like the NVIDIA H100 chip. These processors handle incredibly complex calculations, but in doing so, they generate immense thermal output. Preventing a total meltdown requires extreme heat management. Terrestrial liquid cooling systems are currently forced to drain millions of gallons from regional water reservoirs simply to prevent the hardware from self-destructing. The math is unforgiving. Generative AI requires more power and water than our planetary grid can supply, forcing the industry to seek a structural relief valve off-world. Low Earth orbit offers a pristine industrial frontier. Up there, tech companies face zero land constraints and no municipal zoning battles. It also solves the thermal crisis entirely. By deploying hardware in space, engineers eliminate millions of dollars in cooling costs. They use specialized radiators to pull heat away from the processors and bleed it out into the natural vacuum without a single drop of water. But the true advantage is power. Orbit provides direct, continuous access to unfiltered cosmic radiation, an infinite solar power source that never experiences nighttime or weather delays. This vector schematic demonstrates how we capture that energy using a material called perovskite. It's a highly efficient chemical ink that can be rolled into tight configurations for launch and then unfurled into massive square-kilometer solar arrays once in orbit. Moving to space inverts every terrestrial weakness of AI. It turns Earth's crippling heat and power deficits into an environment of absolute thermodynamic advantage. But putting a server in orbit creates an immediate logistical problem. How do you send a prompt from your laptop and get an answer back in milliseconds without the transcontinental undersea cables we rely on down here? Looking at this diagram of orbital nodes, you can see the solution. Satellites use inter-satellite laser mesh networks to beam information through the vacuum. This method delivers 1,000 times more bandwidth than traditional radio frequencies, and it is completely unaffected by terrestrial weather. For decades, deploying anything of this scale was blocked by a single barrier: the sheer financial cost of breaking Earth's gravity. Today, partially reusable heavy-lift rockets are lowering that financial barrier. Next-generation vehicles like SpaceX's Starship are driving the break-even cost of orbital deployment toward $10 to $20 a kilo. Because the math finally works, the migration has already started. Space startups and telecom giants have formally filed with the FCC to put up to 1 million new satellites into orbit, specifically engineered for orbital compute. This is no longer a theoretical engineering exercise. Plummeting launch costs and laser communications have triggered an active, highly funded deployment race. But escaping our thermal limits brings severe geopolitical consequences. The nation that controls orbital infrastructure gains a significant strategic advantage. China is aggressively pursuing this through the three-body computing constellation. They're launching a planned network of 2,800 satellites designed to process raw intelligence and filter imagery directly in orbit before it ever touches the ground. While the United States relies on a fragmented push by private tech companies, Beijing is executing a unified, state-funded mobilization written directly into national policy. Beyond military dominance, the migration offers a radical legal maneuver. Because space lacks established sovereign boundaries, data stored and processed in orbit technically exists outside the traditional reach of national law. This legal gray area allows for the creation of sovereign data havens. By moving hardware to orbit, corporations can host intelligence on servers that are physically unreachable by terrestrial subpoenas or local anti-monopoly regulations, effectively decoupling their global operations from the laws of any one nation. These untouchable orbital networks reside far beyond the immediate reach of physical sabotage, localized disruptions, and conventional terrestrial cyber warfare. The organization that builds this infrastructure will dictate the future of global intelligence from a height where Earth's regulations no longer apply.